Today our topic is halogenation of alkanes. Halogenation of alkane is an example of a substitution reaction. So first of all, we will discuss what is substitution reaction actually. A reaction in which a halogen atom replaces one or more hydrogen atoms from alkanes in the presence of diffused sunlight or high temperature is known as substitution reaction. So what happens actually? Actually, in the presence of sunlight or high temperature, the halogen atoms replace one hydrogen. After then the other hydrogen, one by one halogen replaces all of the hydrogen from the alkanes. So in this way a substitution of halogen atom takes place. Halogenation of alkanes occurs by free radical mechanism. So what is free radical mechanism? In free radical mechanism, diffused sunlight or high temperature generates free radicals and cause a chain reaction. So now come to what is free radical actually. Free radical is an atom or group of atoms with unpaired electrons. So due to the presence of unpaired electrons, these free radicals are highly reactive. These are the examples of free radicals. So these dots are representing the presence of unpaired electron, and due to the presence of this unpaired electron, free radicals are highly reactive. So once free radical is generated by the presence of diffused sunlight, so a chain reaction starts. This reaction takes place in 3 steps. So what are the steps? The first step is initiation, the second one is propagation, and the third is termination. We will discuss one by one all these steps. First step is initiation step. During initiation, chlorine molecule in the presence of diffused sunlight gives free radical. During mechanism, we show the breakage of this bond by half curly arrows. These half curly arrows actually showing there is transfer of single electron by each atom. Okay, these are half curly arrows. After the generation of free radicals, the chain reaction starts, which is the second step of halogenation. This step is known as propagation. So what happens in the propagation? The free radical, which is highly reactive, convert methane CH4 into free radical. We will show this step by these half curly arrows. So this free radical is giving electron here, and one electron is transferring here to form a bond. So H and Cl form HCl, and this arrow showing transference of one electron on the carbon atom, like this. This is methyl free radical now. Then this free radical is very reactive, and can break the bond of a new chlorine molecule. So what happens? This unpaired electron transfer here, and one electron will transfer here, and other electron from this bond transferred on chlorine. In this way, will form a bond with chlorine and a new free radical is generated. Now again, this free radical is highly reactive. This will attack I will show this chlorine here. Now this electron will transfer here, and one electron will transfer here in this way. Another free radical is generated, and hydrogen and this chlorine will form HCl. Now this is a free radical. Okay, this free radical is highly reactive to break another molecule of chlorine. That's why we are calling this step a chain step, propagation step. Now what will happen? One electron from this bond comes here, and this electron come here to form a bond between C and Cl. So what will be formed? Another chlorine will attach here, and here again a free radical is generated. Now this free radical is again has opportunity to pick another hydrogen. So what will happen? This is showing transference of single electron in this way. So what will be produced? Another free radical is generated along with HCl. Okay. This free radical is again highly reactive. So what would happen? This free radical will break another halogen molecule. So what would happen? Electron will transfer here, another electron will transfer from here. Okay, in this way carbon will attach one more chlorine in place of hydrogen. Okay, and along this another free radical is generated. Now look at this molecule. There is still one hydrogen to be replaced by the fourth chlorine atom. So what would be the next step? Okay, the chlorine free radical will attack now this molecule. Okay, as there is one hydrogen is present, so this free radical will replace this hydrogen too. So one electron will transfer here and one from here to form a bond, and the other electron will transfer on carbon. So another free radical is generated along with HCl. Now this free radical is highly reactive to break another chlorine molecule. Okay, so what would happen? In this way transfers of electron will occur. Now the last chlorine atom will also attached with carbon, and a free radical is again generated. This is free radical. Okay, so this free radical is again generated. Now what would happen? We will move towards the termination step. What would happen in the termination step? Any two free radicals from the whole propagation will form a molecule. For example, I pick this free radical along this. Okay, so what would form? There can be another possibility. For example, this free radical attach to this free radical. That's mean any two free radical from the whole propagation can attach to each other to form a compound. Okay, in this way the termination will occur. As a result of the reaction between the free radicals, different compounds are formed. So after these reactions, all the free radicals are removed from the reaction mixture and do not perpetuate the cycle further. Now we move towards the naming of the products. This is the first product. It is called chloromethane. Okay, ये product chloromethane. One chlorine is attached after the removal of hydrogen. So hydrogen from the methane, so that's why it is known as chloromethane. Now here two chlorine are attached. It is known as dichloromethane. Now come to this. Here three chlorines are attached, so it is trichloromethane. It is also commonly known as chloroform. Okay, and the last product, this, it is containing 4 chlorine atoms attached with one carbon, so it is known as tetra. Tetra means 4. Tetrachloromethane. So each product ends with methane. That means this product is derived from methane molecule. Okay, so this is the naming of the products. Now come to the last point about the reactivity of halogens. Which halogen is more reactive for halogenation and which is less for the halogenation? The reactivity order of halogen is fluorine, highly reactive, then chlorine, then comes bromine. Okay, and the least reactive is iodine. This is the reactivity order of halogens. Fluorine reacts explosively. Chlorine reacts slowly in dark at room temperature but rapidly in strong sunlight. Bromine is less reactive than chlorine and requires high temperature. Bromine requires high temperature or strong sunlight. Iodine is essentially unreactive at all. Okay, so this is the reactivity order of halogens for halogenation of alkanes. Thank you.